So let's talk about how to actually label geometric diagrams. So with angles, there's a few different ways that you might see an angle labeled. If you have 3 points of your angle, one being the vertex and one on either ray, you could name it with angle ABC or angle CBA. The key here is that that letter B, which is where your vertex is, that has to be in the middle. The next one, you might just have a single point there. So you might just have this label as angle A. The key here is you only want to use something like that if you have one obvious angle. You never want to have it where, let's say if you had something like this. If I said A, we wouldn't know if this was referencing this angle here or this angle or even the whole thing. So we would want to avoid that. So angle A can be used just at certain times. You might also label an angle with lowercase Greek letters like alpha or theta. So you could say angle alpha or angle theta. And you can also use numbers, and these are all labeled inside the interior of that angle. So angle 1 or angle 2. When it comes to closed figures like rectangles or any quadrilateral or polygon, you want to make sure to name your figure going either clockwise around or counterclockwise. So for instance, this rectangle could be named A, B, C, D if we're going around clockwise, or counterclockwise if you start with A, it would be A, D, C, B. A name that wouldn't work, for example, could be something like A, C, D, B, because you're going A, C, you're crossing over instead of going around the figure. For triangles, you can name triangles going either direction as well. You put the triangle symbol. For instance, ABC could work. That's going around counterclockwise. Or triangle, if I wanted to go around clockwise, I could say ACB. Now, they don't have to start with A. You could have started with B. So, for example, triangle BAC, BAC would work, or BCA, any combination. If you're labeling the sides of a triangle, it's customary to label those with lowercase letters. And you do it so that the side that is opposite of the angle, they share the same letter. So capital A for angle A or vertex A of that triangle. So the side across from it is side A with a lowercase letter. So side A is opposite of angle A. Side lowercase b is opposite of B, and side C is opposite of angle C. Parallel lines are marked with what we call feathers. So in the diagram above, you can see these little arrows in red. There's two sets of parallel lines here. So the first set is marked with a single feather, and the second set each has two feathers. If you see a box at the intersection of lines or segments, that indicates a 90-degree angle or a right angle, which tells us that those lines are perpendicular. And finally, congruency. If we're looking at two congruent triangles, triangle ABC is congruent to triangle DEF, you can use hash marks and arcs to represent congruent sides and angles. So for example, side AB is congruent since A, B are the first letters there, DE is the first two letters there, so that's congruent to DE. You put a single hash mark on both of those. Side BC would be congruent to EF, so I would put two hash marks. And then the last sides, you could give three hash marks if they're congruent to each other. Just like you could give single, double, or triple arcs. So maybe I would mark these angles are congruent to each other with a single arc, or these two angles are congruent, so they get a double arc to show that they're different than the original ones. And maybe this one gets three arcs and it's congruent to this one, so it gets three arcs. The biggest thing is that you can never assume that any figures are drawn to scale in geometry. So you need to pay attention to the actual marks on the figure and the different symbols used when naming, and that's going to tell you more information than if it would be drawn to scale.